This is question 22 on chemistry from section 2 of the 2020 BMAT. So we're given the melting points for two compounds BrCl and BrI. We can see that BrI has the higher melting point. And we're asked, why do these melting points differ? So our 5 different statements read that the BrI covalent bond is stronger than the BrCl covalent bond. Secondly, that chlorine is more reactive than iodine, so this breaks away from bromine more easily. Thirdly, that the forces between BrI molecules are stronger than those between BrCl molecules. Fourth, we have iodide ions are larger than chloride ions, and so iodide forms stronger ionic bonds with bromide. And finally, we're told that iodine atoms are larger than chlorine atoms, and so the BrI covalent lattice is stronger than the BrCl covalent lattice. So where shall we begin here? Well, we need to think about the process that's actually happening with respect to the BrCl and BrI molecules during this melting process. And so firstly, what does a bromine halide molecule look like? So we know bromine forms a single bond to another bromine to form a Br2 molecule. And chlorine and iodine both do the same to each other because halogens have one unpaired electron, so form a single covalent bond. And so by extending that logic to mixed halides, we can consider BrCl and BrI as forming a single covalent bond between the two atoms. And so BrX is a general form of writing BrCl and BrI. And so in the solid state, what does this look like? So we're going to have many of these BrX molecules joined together, but how? So because they've already formed their one and only covalent bond from that unpaired electron, they simply stack up and are joined by intermolecular forces. This holds them together in the solid state. And so what happens to this when it melts? So if we apply heat, we partially break these intermolecular forces to form some sort of loosely bound structure, like so, which is a liquid. So bearing this process in mind, let's take a look again at each of our statements. So, do the melting points differ because the BrI covalent bond is stronger than the BrCl covalent bond? Well, we're not actually breaking any covalent bonds in this process. Instead, we're just pulling the molecules apart while keeping this bond intact. So we know this one is not correct because it's describing the wrong type of force. So what about statement B? This says that chlorine is more reactive than iodine, so it breaks away from bromine more easily. Well, is chlorine even breaking away from bromine at all? We've just said with statement A that the bond between bromine and chlorine and that between bromine and iodine is not breaking in this process. Instead, the bromine halide molecules are simply becoming more separated. So again, this second one is not correct. Then what about statement C? This says the forces between bromine iodide molecules are stronger than those between bromine and chloride molecules. Is that correct? Well, firstly, this is describing the right kind of force. So we can see that it is the intermolecular forces, the van der Waals and dipole-dipole forces, that are being broken during this process, at least partially, rather than the covalent bonds. And is it the right way around? So bromine iodide has the stronger melting point, and therefore it will have the stronger intermolecular forces. And that's exactly what is said in statement C. So as a third sort of check, does this make chemical sense? So we know iodide has many more electrons than chloride, and so bromine iodide, it has more electrons as a compound, and so it will therefore have stronger van der Waals forces, which makes sense. So all in all, we know statement C looks pretty correct. Now to be safe, let's make sure statements D and E are both wrong. So D says that iodide ions are larger than chloride ions, so they form stronger ionic bonds with bromine or bromide ions. Would that make sense in this situation? Well, we know we're not dealing with ions because these compounds are between elements with a very similar electronegativity, all in the p block. And we know these sorts of compounds do not form ionic bonds, they form covalent bonds. And furthermore, bromide would have no interest in iodide or chloride, of course, because these are all negative ions, so there will be no ionic interaction that is favourable. And so everything about D seems pretty wrong. So finally, in statement E, we're told that iodine atoms are larger than chlorine atoms, and so the BrI covalent lattice is stronger than the BrCl covalent lattice. Does this make sense? Well, this certainly seems closer to the truth than the previous statement, but what's the flaw here? So the way that it's described as a covalent lattice suggests that this whole thing in the solid state is connected by covalent bonds. Is that true? Well, no. We know that each bromine is only connected to one X, or chloride or iodide, rather than being connected to a load of different atoms. And these are instead held together by weaker intermolecular forces than covalent bonds. So it's wrong to compare the covalent lattices. Instead, we should be talking about intermolecular forces, like we were in C. And so statement E is not quite correct, so we can mark it wrong. So we've seen that the only statement that makes full sense and explains this observation is statement C, that describes the intermolecular forces being stronger in BrI than BrCl. So C is our final answer.